Hi everyone, welcome back to our YouTube channel, and this is Pandao Anaheima from STEM 12-2, and for this video I will be discussing three topics. These are the molarity, the boiling point elevation, and the first law of thermodynamics. So I will be giving some examples for each topics. So the first topic, which is the molarity. In order to get the molarity of a problem, we will be using the molarity formula, which is molarity is equals to moles of solute over the liters of solution. So for the problem number 1, you have 3.50 liters of solution that contains 90.0 grams of sodium chloride or NaCl. What is the molarity of that solution? So we will be using the molarity formula, which is M is equals to moles of solute over liters of solution, as I've mentioned earlier. So here are the given values in the problem. 90.0 grams and the liter, which is the 3.50 liters. As you can see, there is no moles of solute mentioned in the problem. Therefore, we will be converting the 90.0 grams into mole. Note that for every mole, it is equivalent to 58.44 grams. So let us calculate it. 90.0 grams times 1 mole over 58.44 grams, we will be having 1.54 moles of sodium chloride because the unit grams will be cancelled out. Now, let us find the molarity of the problem. Let us substitute the given values of the problem into the formula we will be using. So molarity is equals to 1.54 moles of sodium chloride over 3.50 liters of sodium chloride. So we will be having 0.44 molarity of sodium chloride, and that will be the final answer for this problem. So for the second topic, which is the boiling point elevation, we will be using the boiling point elevation formula, which is delta TB equals KB times M times I, where the delta TB stands for the change in boiling point temperature, the KB stands for the boiling point constant of water, which is 0.512 degrees Celsius over M. The M that stands for the molarity of solution in mole over kilogram. Lastly, the I that stands for the number of particles the substance will dissociate into. So for the first problem, calculate the boiling point of a 1.5 m aqueous solution of sodium chloride. Assume that you are at sea level. So we will be using the formula I've mentioned earlier. So let us substitute the given values to the formula that we will be using. So delta TB is equals to 0.512 degrees Celsius over M, that is the boiling point constant of water, times 1.5 m times 2, which is the number of particles the substance will dissociate into. And we will be having 1.5 degrees Celsius, but that is not the final answer yet. Note that the boiling point of water is 100 degrees Celsius, so we will add 100 degrees Celsius to 1.5 degrees Celsius, and we will be having 101.5 degrees Celsius as the final answer, and that will be the boiling point of a 1.5 m aqueous solution of sodium chloride. For the last topic, which is the first law of thermodynamics, we will be using the formula delta U equals Q plus W, where delta U is the change in internal energy of the system, the Q, which is the heat exchange between the system and the surrounding, and the W, which is work done on or by the system. So for the first example, a gas in a system has constant pressure. The surroundings around the system lose 62 joules of heat and thus 474 joules of work onto the system. What is the internal energy of the system? So to find the internal energy of the delta U, we must consider the relationship between the system and the surroundings. Since the first law of thermodynamics states that energy is not created nor destroyed, we know that anything lost by the surroundings is gained by the system. The surrounding area loses heat and thus work onto the system. Therefore, heat and work were positive in the equation delta U equals Q plus W, because the system gains heat and gets work done on itself. So let us answer the problem. Delta U is equals to 62 joules, which is the heat in the problem, plus the 474 joules, which is the work of the problem. We will be having 536 joules, and that will be the final internal energy in the problem. That will be all for this video. I hope you learned something, and don't forget to give this video a thumbs up, and don't forget to subscribe to our YouTube channel. And that will be all. Bye!